For decades, the public sector has relied on a specific mechanism to oversee infrastructure spending, the post-project forensic audit. This method is structurally limited. Discovering financial leakage after capital disbursement means the primary asset is already gone. Traditional oversight relies on paper documents and human-curated site diaries, which often mask critical delays, material substitutions, and compounding cost overruns. A reactive, backward-looking review process leaves public funds perpetually exposed to multiple vectors of leakage. Securing modern infrastructure budgets requires a shift toward preemptive accountability. This model engineers a financial architecture where executing an unverified payment is physically impossible. The Public Sector Oversight Suite by Faro Fonds Digital provides the framework for this type of automated control. This federated technology stack integrates artificial intelligence, computer vision, and orbital telemetry into a single oversight layer. By automating these checks, the suite replaces subjective reporting with a rigid, cryptographically secure chain of custody. The first layer of the stack is the digital site diary, which establishes ground truth at the site level. Site agents and municipal inspectors must provide GPS-tagged, time-stamped photographic evidence for every daily log entry. The system uses advanced computer vision algorithms to dynamically scan visual data, verifying that reported progress matches the physical reality of the site. If a contractor logs a foundation trench as complete, the entry only processes once the algorithm actively detects a genuine excavation. This neutralizes the ability to submit backdated reports, ensuring municipal decision-makers act on unassailable physical facts. The second layer of the stack is the Miami Compliance Engine. This module functions as an automated auditor for tender documents and bills of quantities. It deploys natural language processing to autonomously read and interpret contractor claims as they are submitted. The engine instantly cross-references claims against the original signed contract, the master bill of quantities, and the project's technical specifications. At a scale impossible for human auditors, the system flags discrepancies like line item padding or unauthorized material substitutions. This protects the budget from incremental leakage and the fraud often hidden within complex infrastructure variations. The third verification vector provides a macro-scale view, the Alpha Earth Geospatial Tracker. This system integrates automated change detection data from Copernicus Sentinel-2 satellites with local cadastral boundaries. If a contractor claims 80% completion on a bridge, while satellite imagery shows only earthworks, the discrepancy triggers an automatic red flag on the dashboard. For complex infrastructure projects requiring higher resolution, this orbital data is supported by a localized drone backup protocol. Municipal inspectors deploy these drones to capture hyper-accurate three-dimensional photogrammetry data for verification. This dual-layer architecture, satellite macro-tracking and drone micro-verification, prevents premature payments without requiring constant physical site visits. Projects also face cost overruns from extension of time claims, where contractors cite adverse weather as the cause for delays. To adjudicate these claims objectively, the suite uses the Weather Impact Adjudicator. The tool correlates historical, hyperlocal weather data directly with the project's critical path schedule. When a rain day delay is claimed, the adjudicator checks the actual recorded conditions against explicit SANS-defined thresholds for that specific location. By replacing subjective arguments with hard meteorological data, the state saves millions in unnecessary standing time payments. These systems converge at the final line of defense, the ERP shield. This module is an impenetrable API firewall sitting between project data and the council's financial systems, such as SAP or Sage. A payment certificate cannot be pushed to the ERP system for processing unless all 4 AI verification engines have successfully validated the work. While forensic auditing looks for mistakes after money is spent, this system physically blocks the transaction if the work cannot be independently verified. The ERP shield enforces fiduciary responsibility by removing human override capabilities from the payment process. Ground truth, contractual truth, geospatial reality, and environmental data are unified here into a single compliance mesh. The state simply cannot pay for unverified physical progress. This shift replaces vulnerable, curated narratives with algorithmic, zero-trust data integration. The Faro Fonds Digital Suite empowers infrastructure leaders to enforce physical discipline and guarantee absolute value